Okay, so we left off here yesterday, and I just wanted to mention just briefly like what your strategy would be for this question. So there's two possibilities. If this coefficient here is not positive 1, what you need to do is you need to divide everything, every single term by 2, or whatever this value is. So you got to go through and divide every term by 2, including this one and that one. Okay? Then you could do synthetic division. So once you've done that, like you would have 2x to the 3 minus 4x squared minus a half x plus 5 over 2 divided by x minus a half. And now you could go find your a term, right? You could set this equal to 0. You get that a is a half. And then you can go through and do your synthetic division as you normally do, okay? It means that you might get fractions. Okay, or you can just use long division as usual and not have to divide everything by 2. Okay, so your options are, if you want to use synthetic division, got to divide everything by whatever this number is. Okay, it's got to be plus 1. It's got to be plus 1x. Okay, you might get fractions, whatever. If you don't want to do that, you can use long division as usual. You can use this as the thing off to the left, and it's all good. One last thing, if you do synthetic division, you also need to remember, so this is a star. When you get your remainder, you actually, because you divided everything by 2, your remainder will be cut in half. So to actually get the correct remainder, you have to multiply everything by whatever you divided by. So remember, remainder at end, if there is one, it needs to be multiplied by whatever you divided by. So in this case, it would be 2. Now, I've never seen that on the exam. So whatever you divided by at the start. Never seen it happen, but it could happen. That's a lie. They did do it one time, but the solution was we'll just do it the long division way. Okay? So, we have limited time today, so you can always check back in the video if I'm going a bit too fast here, but it won't happen too much. Might come up in the exercises just for practice, but honestly, I would just do it using long division. It's going to take you an extra, 20 seconds. So, here we are today. Please add the goal. So, by the end of the lesson, you're going to now know how to factor polynomials of I should say a higher degree than 2. So we're going to come up with a really good strategy. So we're going to learn how to factor polynomials of degrees greater than 2 by using the factor theorem and synthetic division. So this will be really important. What's the factor theorem? Making sure you know how to use synthetic division. After this, you guys will be so powerful. You'll be able to do so much. I can tell you're excited. And yeah, this is something that just over and over and over again is going to come up all throughout the course. So we'll hopefully get really good at it. Okay, so we might skip this review today because we sort of did the mental math already off camera. But yeah, it's just review from grade 11 being like, hey, do you remember how to factor this? What method would we use? Yeah, decomposition. Why? Because the a term's not positive 1. So this is a decomp question. Oh, let's check if there's a greatest common factor you can pull up. But yeah, this is going to be decomp. This is a difference of squares. So it's like, okay. That's stuff you did in grade 11. So now, what if I gave you something that had an x to the 3 in it? And I said, okay, factor it. Right? Well, that's what we don't know yet. We're going to learn how to do that. Yeah, but it has something to do with synthetic division. So let's look at a long division question from yesterday. So when a polynomial is divided by a binomial, that's in the form x minus a. Okay, so that's in this format. The remainder is somehow related to the polynomial and the constant term of the divisor. Okay, so here's the original polynomial. And now we're going and we're dividing by x minus 2. Okay, so they show us all the work. Here's the answer they get. So remember, this is called the quotient. This is the divisor. And this one here is the dividend. It's the original thing you're dividing, okay? So they go through, and it's like, oh, here's the remainder. Well, there's actually something very, very special about the remainder. It just so happens that if you take the divisor x minus 2, okay, and you solve it for a, so you go x minus 2 equals 0, and then you get x equal 2, and that's your a value. If you go and evaluate the original polynomial, when x is 2, or in other words, plugging in your a value, so you go pop it in, evaluate it out, so you get all the work, we get 47. What are you noticing about the 47 there? Yes, hey, that was the remainder from before. Okay, so it turns out that's actually important. That's called the remainder theorem. Okay, so it says the value of the polynomial when x equals 2. So when you take that x minus a, you set it equal to 0 and you solve it. Okay, when you plug in that number, it's equal to the remainder when the polynomial is divided by x minus 2. That's the remainder theorem. Okay, stick that in your brain tank because that's going to come up. That's going to come up again in a moment. All right, let's try some questions. So here's the remainder theorem again, just stated nice and clear. So when a polynomial, we'll call it p of x, is divided by a binomial in the form of x minus a, and all this stuff here, a is an element of z, just means that a needs to be an integer. Right? Integers are like minus 2, minus 1, 0, 1, 2, okay? So it's just saying this has to be an integer. It can't be like a fraction or something like that. Okay? The remainder is p at a. So let's try it. We got a couple of questions. Here we go. We're going to use this polynomial. Let's see what the remainder is when we divide it by, say, x minus 1. So if you believe the remainder theorem, then you say, okay, well, I'll just set this equal to 0. A is 1. So if I pop in 1 into this, I should get the remainder. Let's see. I'll just show all the work. There it is. Give you a moment maybe. So what do we get? 1 to the 4 is still just 1, so I get 3. 1 to the 3 is still just 1, so I just get 7. Now here, be careful, you get subtract 1. 1 squared is 1, and then you got the subtraction in front. 14 times 1 minus 3 is 11. Okay? I'm going to recopy my p at 1. Now what do we get there? 10, 9, what is it? Minus 20? Is it minus 20? Wait, yeah, okay, positive 20. So apparently that's the remainder. Oh, yeah. So I'm just going to write remainder question mark. Let's check. So it says verify this is true in A by using synthetic division. So let's go do it. Let's do the synthetic division. So my A term is 1. So I'm going to go 1. That. Are we missing any powers? No, so we go 4, 3, 2, 1, and we got a constant term. So pop in the coefficients. So 3, 7, negative 1, 14, negative 3. And then start doing your thing. Bring that one down. 1 times 3 is 3. Add those up, you get 10. 10 times 1 is 10. Add those up, you get 9. 9 times 1 is 9. Add those up, you get the 23. 23 times 1 is 23. Add those up, you get 20. So this should be the remainder. Let's see, let's double check. So you would get 3x. What's the power once you do the division? 3 plus 10x squared, and then plus 9x plus 23, and remainder 20. So, did it seem to work? Excellent. Perfect, perfect, perfect. Let's try B. So just down here. So I know this is all rather fast, but we all believe the remainder theorem. I'm telling you, it's a real thing. It's been checked out. The doctors agree it's in. Okay, it's a thing. So if we believe that, What's the a value for b? Negative 3, very good. How do we get it? We set this equal to 0 and we solve for x. So let's really quickly use the remainder theorem. Pop in negative 3 here. Let me know what you get. So I'll let you do the work on your calculator, maybe, I don't know. You're gonna get some large numbers. So I'll just write down the work in the meantime. So we're gonna go 7. Where did it go? That's a lie. It's 3, negative 3 to the power of 4, plus 7, 3 to the 3, subtract negative 3 squared, plus 14 times 3, subtract 3. What's the remainder? 14. Oh yes, I started writing 3, but it's negative 3. You're 100% correct. Yeah. So all those brackets, negative 3. Let this be an example of what happens when you start getting disorganized and you start cramming things in. That's always what happens. Anybody got the remainder yet? 0. Let's get some confirmation. One more person. 0. Excellent. The remainder is 0. So down here it says in B, the remainder is 0. So what do we think that means? Okay, yeah. The remainder is 0. But okay, in terms of if we were trying to factor this, what does it mean as far as the divisor? So the divisor x plus 3 goes into this evenly. Right? If there's no remainder, doesn't it mean that the divisor went in evenly? Yes, so what does it mean? It means that this thing is factorable. Very good. So what does this tell you about the divisor? So the divisor, x plus 3, evenly divides the polynomial. So therefore, we can factor it. It's amazing. So if the remainder is 0, then it's telling us that that divisor evenly divides the polynomial. Well, that'll be handy. I'll just let that sink in. Is it sinking in? Nobody watches these. We don't want to ruin our aha moment. So in example 1b, the remainder was 0. This means the divisor x plus 3 is a factor of the polynomial. This is a special case of the remainder theorem. And that special case is called the factor theorem. Okay? So let's recap. Remainder theorem says that, hey, if you take a polynomial that's x minus a and you plug in the a value, it will tell you the remainder of the division. Okay? The factor theorem goes one step further, and here it is. It says, all right, for every a that's an integer, if you have a thing that is in the format x minus a, it is a factor, i.e., it divides evenly. So it's a factor of the polynomial p of x if p of a is 0. Are you down with the math lingo?
Yes.
All right. On the exam, 10% of your exam is like explain this type questions. Like in English, tell me about this, or explain why this or that is. They often will have a question about remainder theorem or factor theorem. Okay? So like, do you actually need to be able to spit this out and spit that out and know what it means? Yes. If you want to get those 1 or 2 marks. It's 10% of your exam. Okay? Don't throw away 10% of the exam because you don't want to write a couple sentences, all right? So we'll work on them. I'm just saying, like, go back tonight and quiz yourself. Like, okay, what's the remainder theorem? Can I say what it is? What's the factor theorem? Okay? There's always lots of confusion between the two of them. because no one seems to care. I don't know. Okay, so we'll do a couple of these. We're not going to do all of them, but it just says, okay, here's a polynomial. Let's just call it p of x. So we'll say p of x equals. And it's just saying, which one of these binomials actually factor this? So I threw it in here for you. To be a factor, p of a has to equal 0 from x minus a. So let me look at my notes because I did a couple of them. Yeah, let's try a. So is this a factor? Well, solve it like that. That's your a value. And pop it in here and see if we get 0. So is p of 1 equal to 0? Question mark. Let's see. 1 to the 3 plus 2, 1 squared minus 13 times 1 plus 10.
Yeah.
I'm hearing a yes. All right, let's see. So you get 1 plus 2, subtract 13 plus 10. So let's see, that's 3. Plus 10 is 13, minus 13 is 0. Yes. So this is what I like to do. P of 1 equals 0. Therefore, x minus 1 is a factor. That's a C, is a factor of p of x. Now, I think many of these end up being, I know D is, like I did a couple of them ahead of time. I know D is, and I'm not sure about the other ones. One of these doesn't end up working out. Now we have limited time today, so I'm going to leave it at that, and we're going to try an actual question. There's something down here to note. So did you notice that all the factors of the polynomial must have constants that are factors of the constant or end term of the polynomial expression? So this gives you a place to start guessing, because basically we're going to try to factor stuff, but they're not going to give us, they're not going to be like, hey, try x minus 1 or try x plus 1. You're going to have to guess. Okay, so what that is saying down there is saying, hey, look at the constant term. Is negative 1 a factor of 10? Like, does it go in 10 evenly? Yes. I'm telling you that this is one that works. 5. Does 5 divide 10 evenly? Yes. So, just because 5 divides 10 evenly doesn't guarantee you that this will be a factor, but it must be true that this goes into that. Okay? So it could be possible that, hey, this one goes in, but this might not end up being one of the answers. Okay? But it gives you a starting point. Is everybody clear? Excellent. If you're not clear, you're going to be clear on the next example because we're going to be doing every single step. I saw a hand go up. Yes, miss.
The only one that doesn't work is C, by the way.
Is C?
Yeah.
Okay, so and you got confirmation? Good job. I really appreciate that. So that doesn't work. All these work. So let me demonstrate it. 2 goes into 10 evenly? Yes. But this doesn't work. Okay, so it gives you a starting point. You need to find numbers that divide this evenly. It gives you a starting point. Then you got to go see if p at that number equals 0. If that's the case, it's a factor. And then we can do synthetic division and start factoring. How many times did I say factor?
If it was like, say, x plus 3, you can just automatically...
Yes, very good. So if I said, hey, does x plus 3 have a chance of being a divisor? Immediately, without doing any work, you'd be like, no. Why? Because 3 is not a factor of the constant term 10. Thanks for really clarifying that, Kevin. No, it's a good. I should have thought of that. Okay, so let's put those two ideas together. If we can get this one question done before the grad meeting, that'll be great. Then you guys will subscribe to my channel and go look at the rest of the video tonight, right? Or tomorrow in class, instead of teaching again, because I'm just going to keep going when you guys leave, I'll just sit back and I'll hit play on YouTube. That would be the dream. Okay. All right. So we're going to put all those ideas together. So step 1. We have to find a factor by using the factor theorem to get a remainder of 0. Then we can use synthetic division to factor, and you may need to repeat that step until you have the entire polynomial factored. Okay? So, factor fully. This one here. Okay, just a bit of chatter. I know we're excited about this. So it says, since the ending constant is 6, all the possible factors of 6 are right there. So that's a step you would have to do on your own. Right, but plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So this is how I like to do it. I like to say, okay, well, I'm going to go with the easy ones, like I'm going to start with the 1. So I'm going to say try x plus 1. Oh. X plus 1. So what's the a value? Very good. So a equals -1. So let's go plug it in. So we're going to try going 2 times -1 to the power of 3 minus 9, -1 squared plus 7, -1 plus 6. Okay. Now, is this equal to 0? So let's see. You get 2. You get -2. That's positive. You get -9. -7 plus 6. So yeah. I don't even bother figuring it out. Just like, I just look at it and I'm like, yeah, not 0.
Ain't no way.
No way.
So then would we try x minus 1 or would we go?
You gotta try. So that's the thing about this process is the constant term gives you an idea of what is possible. You need to find one that works. Okay? Now on the exam, it's almost like I've rarely seen people try more than 1 or 2. Like they usually make it that like 1 or 2 is gonna work or something like that. Like there will be more than one answer because when we factor this, we're gonna have 3 binomials. So there are 3 possibilities in here that work. Okay?
Wait.
Yeah, I'll point that out at the end. But let's try x minus 1. So I think it's really important to write the binomial you're trying so you don't get confused. So I just say try x minus 1. So that would mean a is 1. Doesn't work? Okay, so I'm just gonna say no, doesn't work. I'll take your advice. I know what does work. I have it all here. Let's try.
Yeah, because that's just 2.
Let's try x minus 2. So then a would be 2. Let's see what happens. So 2. Okay. So this would give us 2 and 3 is 8, times 2 is 16. That's 4 times 9 is -36. That's 14 plus 6. So let's see. 20 plus 16 is 36.
Oh, yeah,
yes, that is 0. So this is what I like to do. I say, therefore, look back here. It's a good thing we wrote it down. X minus 2 is a factor. So now we can do synthetic division, right? A is 2. So go to your polynomial, grab the coefficients. So the coefficients are 2, -9, 7, 6, 5, 4, 3, 2, 1. Okay, bring that down. 2 times 2, 4. Add them up. You get -5. 2 times -5, 10. Add those up, you get 17. Oh my god, I ended up with this.
No, you get -10.
-10.
Oh, I get negative. I was like,
Oh, yeah, because it's -5.
this is how you know you made a mistake. So let's just say I kept going. 2 times 17, 34. What should I get here? 0. So unless I made a mistake here, which is possible, but it's kind of nice because it will help you catch mistakes. See, I made a mistake on the sign on the 10. Totally on purpose, just so you guys can see what's possible. So yeah, -5 times 2 is -10. That gives me 3. Sorry, -3 rather. 2 times -3 is -6. There we go, we get 0. So now remember, we're factoring this thing. So what does it look like? Well, the answer so far is x minus 2. So that was the thing we just divided by when we plugged in 2. And then what's going to be left? Well, what's the power?
2x squared minus 5x minus
Yeah, so remember, it started on a 3. Once you divide, it'll go down to the next one. So it's going to be 2x squared minus 5x. Subtract 3, remainder 0, so we don't need to write it.
Then do we have to decomp?
Yes, so now you need to either repeat the process using the remainder theorem and the factor theorem and say, hey, you know, what goes in there? Or if you say, well, that's just a decomposition question, so I can now factor that. Okay, so let's go ahead and factor it. So we can just use decomposition. So over here, I'm going to do the decomp. Right, this one is one that you see all the time, but we're looking for 2 numbers that multiply to -6.
It's 1 and
And have to add up to the b term, -5. So yeah, what are they?
-6 and 1.
-6 and 1. Okay, so I'm going to show the work in case you don't remember. But really, you got to be a pro at decomp. So when I finally get to my answer here. Switch colors for a second. What can we factor out of the first two terms? 2x.
X minus 3.
And then when you factor out the 2x, you get x minus 3. Then you look at the last two terms. What can you pull out? You must get x minus 3. So plus 1. So fully factored. This thing is x minus 2. This thing factored to 2x plus 1, x minus 3. And you successfully factored a polynomial that had a degree higher than 2. So generally the degree, so this is what I was talking about before. If the degree is 3, you will have 3 binomials, okay? Maximum. Sometimes you get binomials that are the same, okay?
Wait, so do we have to keep on going and try out the rest of the...
Yeah, so if I gave you one that was a power of 4, so say it was a power of 4, once you get to this step, you'd still have a power of 3. So you'd have to do the whole synthetic division process again. And then once you get to a power of 2, you're likely looking at decomposition or the factoring strategies from grade 10 and 11.
So we
Okay.
don't...
Yeah.
Wouldn't it just be easier to like cut out like plugging in the constant and just go straight into synthetic division?
But then you don't know if you're going to get a remainder of 0. Yeah,
You can check if you have a remainder or not.
how like I think I see what you're saying. You're saying like, hey, if I do the synthetic division, if I don't get a 0, then I know that didn't work. Yeah, that's basically what we're doing over here. Yeah. Now, if you think that this is faster, sure, do it that way. But you got to understand, for the theory part of the exam, like the reason we're doing this is because of the factor theorem, right? So the remainder theorem says if you plug in a value, you get the remainder. The factor theorem says if that remainder is 0, then you just found a factor of that polynomial.
So,
Okay.
So now don't we have to do a equals plus or minus 3 to look for other...
No, we're done.
Oh, so the moment that
Right.
we get one solution, it's...
Oh yeah, the moment that you find one, roll with it, right? You just found something that gave you 0, start doing synthetic division.
Okay, so there's always going to be one answer.
Yeah, well actually, what would have worked? Would 3 have worked?
Yeah.
Right? Yeah, because it's a factor. 2 would have worked, and -1/2 would have worked, but that one would have been tricky to get. So yeah, we're not gonna do that.
Oh, okay.
Anyways, I think the best thing we could do is just do another question. Right? There's a lot of stuff happening here, right? So let's try this one. So basically, it should just say, factor f of x. Okay, so your first step is like, okay, so I'm trying to factor, and I'm going to look at the constant term. What's possible? So 48 is divisible by plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't work. And there's probably more, right? You don't need to list out every single one. I guarantee you on the exam, there's always an answer that's like 1 or 2 or something like that.
8 plus or minus 6.
Yeah. Does 6 work? Yeah, 6 works, whatever.
6 times 8.
So let's just try. So let's just say, okay, so try x plus 1. If you're trying x plus 1, the a value when you solve this is -1. Okay, and do you need to show your work? Not necessarily, but it doesn't hurt. I've seen lots of people not write it out and then make stupid mistakes. I'm prone to making those kind of silly mistakes, so I'm gonna write it out. Let's see, you get -1, you get 1 times -8, so you get -8, subtract 4. Okay, now here's what I learned from this. I am really far away from 0, right? Like I get -13 plus 48, so I'm really far away.
Yeah.
So I might go and just try x plus 2. I'm not gonna bother with -1. It's not, or x minus 1 is probably not going to make that much of a difference. So if I'm trying x plus 2, then a is -2 when you solve it. And now let's see. You can do this. You can be like -2 plugged in there gives you -8. -2 squared is 4 times -8 is what?
32.
-32. -2 times 4 is -8, and then I have plus 48. So let's see. I get negative 40, negative 48. So this indeed is 0. Agree? Right, so therefore, x plus 2 is a factor. Please always state what you're doing there because you will avoid brain farts. So now I'm going to do synthetic division. So I'm going to plug in negative 2. I'm going to grab my coefficients. I'm not missing any power, so I'm going to go 1. That's that one. And then I have negative 8, 4, 48. Let's see if I get it right the first time. Bring down the 1. 1 times negative 2 is negative 2. Add them up, you get negative 10. This sometimes that one is 20. 4 plus 20 is 24. 24 times negative 2 is negative 48. Perfect. Let's leave that up for a moment. Now remember, because you're factoring, when you write your answer, you're like, okay, well I just divided by x plus 2, so that's part of my answer. And then from the synthetic division, I get 1x squared minus 10x plus 24, remainder 0. Now, can you factor this?
Yes.
Yeah, that's just one of those easy ones from like grade 10. So two numbers that multiply to 24, but add to negative 10. 6 and 4, perfect. So, and what about the signs?
Negative 6.
Negative 4. There, you factored it. You're done. So, looking back, numbers that could have worked. Negative 2, positive 6, positive 4. So there's usually more than one answer, right? So when I was back at this stage, had I tried one of those, I would have gotten 0. Okay? And like I said, on the exam, like they never make it like the really big numbers. They're so predictable like that because it's a timed exam, so they can't give you like things that take too long. So in my experience, generally, if you stick to the plus or minus 1, plus or minus 2, it'll usually work. Yeah, usually. I mean, they make a new exam every semester, so you never know. But in the past, that's the trend. Do you want to try another one?
Like no, but I guess
We have some time. How long are we at? 35 minutes. I don't really like them being longer than 40. I think we're good. We did 2.
no. It's so tedious.
How about I just get you started on this one? Okay, so you're looking over here, right? And you're like, okay, so plus or minus 1 divides 72, plus or minus 2. How do you know if 3 divides it evenly, by the way?
Add 9.
Yeah, everybody sort of said it, like, if you add up the digits, and that's divisible by 3, then 3 goes in. So 7 plus 2 is 9. 9 is divisible by 3, so 3 goes in. That's probably enough. Like, you're not going to need any more. Now, I'm going to cheat. I'm going to look, because I did this before. I got that x plus 2 ended up working. Right? But how would you have known that? You would have to plug in negative 2 and make sure you get 0. Okay, so I'm just going to write f at negative 2 equals 0. You can confirm that yourself. All right, so now my a value for x plus 2 is what? Be very careful. The a value
Negative 2.
is negative 2, okay? So I go negative 2. 1 is the first coefficient, and then the x of the 3 term has a negative 2, the x squared term has a negative 17, the x of the 1 term has an 18, and then 72. So bring down the 1. 1 times negative 2 is negative 2. Now you have negative 4. Those two things multiplied give you 8. So now you get negative 9. Those two things multiplied together give you positive 18. So you get 36. Negative 2 times 36 gives you the negative 72. You get 0. So answer. Now you got x plus 2. Don't forget that was the divisor. And now, what's the starting power? We used to be 4, now we are 3. So it's 1x to the 3 minus 4x squared minus 9x plus 36. Now what?
You have to do it again.
Do the whole thing again, because you still have, I don't know how to factor this. That's bigger than 2. So whole process again. Now you're looking at 36. So you're like, okay, plus or minus 1, plus or minus 2, plus or minus 3, dot, dot, dot. Again, I'll give you, this is where I'm going to stop. But I'll tell you, now there may be more than one answer, but I'm going to tell you. Yeah, I got that, that x minus 3 is a factor.
So what's the actual answer?
Right, I can give you the, so once you do all the work, the answer you're gonna get is x plus 2, x minus 3, x minus 4, x plus 3. Okay? So that's your final answer until factor. Now, I've never seen them give an x to the 4 question on the exam. So they seem to just stick to the x to the 3 so that it's not like such a long question. But you should be able to do this. I'd say, hey, if you can do this and you have no issues, like you're ready to rock and roll, okay?
And this would be all expected to do without a calculator, right?
Yes. Yeah, I remember in grade 11 when I was such a pain, or I'm like, no calculator, no calculator. This is why. 90% of the marks on the exam is no calculator. Yeah. So the more practice you do, you'll get better at the mental math. Yeah. Yeah, and whatever. Like, I get it. We all have phones in our pocket, but what did you find?
What?
You know, somebody's phone. Okay, there's one last thing I want to do. Wait a second. Where is the question I'm looking for? That's not the one. No. Did I miss it? Is it down here? Okay. Well, in your notes, you should have a question that says, what's the value? I'll type it out. Oh my goodness. I don't know why it's not in me. You should have it in your notes. Let me know. I'll put that in. What value of b will ensure x plus 3 is a factor of b x to the 3 minus 2. Do you guys have this one in your notes? No, okay, just add it, I guess. So this is just a question I got from our homework. Okay. Now, if you're Chen, the favorite thing that you're going to say is like, well, you didn't cover this one in class. But that's because this question is a consequence of if you understand the factor theorem and the remainder theorem, you should know what to do. Now, I can't cover every question in the world. There's an infinite number of questions. But this is one that comes up on the exam every now and again, so I will cover it. Yeah. So let's see. Well, how would we know? So what value b will ensure that x plus 3 is a factor of that? Well, what does the factor theorem say? Yeah, you could go backwards. It could be other ways. I'm going to do it this way, just in case the numbers get complicated. But yeah, if x plus 3 is a factor, then if I plug in the negative 3 plugged in for x would yield a value of what? Of 0, right?
Oh, right.
So if they were asking you as a theory question on the exam, you would say, well, if x plus 3 is a factor, then if I were to plug in negative 3 for x, I would get a value of 0, and then you would say, by the factor theorem. And they would consider that an appropriate answer. So what am I going to do? Well, if that's true, I'm going to set this thing equal to 0, and I'm going to plug in negative 3 for x, and I'm going to solve for b. And that's it. It's that easy. Boom. So now solve that equation for b. So now you're back in like grade 9. So let's see, you get, watch me as I like to make a stupid mistake. So you get negative 27b, you get positive 9 times negative 2, so you get negative 18, plus negative 3, subtract 6, so you get negative 9. So that gives me negative 27. I'm gonna add 27 to both sides. So 0 plus 27 is 27. Yeah, this gives me negative 27, right? So I'm going to add 27 to both sides, divide by negative 27, you get b equals negative 1. You're done. Okay, I'm stopping the recording there. Thanks so much for your attention. It was a long one, I'm sorry.